For 9 episodes, we've explored the solar system. We found volcanoes on moons, oceans under ice, storms bigger than planets, mountains made of frozen methane, geysers erupting into space, comets that remember everything, asteroids that threaten everything. We found ice blades as tall as skyscrapers, backwards orbiting moons, a heart-shaped glacier on a dwarf planet 3.7 billion miles from the Sun. We found worlds stranger than science fiction ever imagined. But the strangest world we found, the one you're standing on. Earth is the solar system's biggest anomaly, and we're only now understanding why. December 7th, 1972. Apollo 17 astronauts captured this photograph from 28,000 kilometers above Earth's surface. The blue marble, the most reproduced image in history. For the first time, humanity saw our planet as it truly is, a sphere. Oceans covering 71% of the surface, continents drifting, clouds swirling. Alive. And for 50 years, we used this as the baseline, the template, what planets should look like. But we had it backwards. Mercury, cratered, dead, no atmosphere, temperature swings from 430 degrees Celsius in sunlight to minus 180 degrees Celsius in shadow. Venus, hellscape. 465 degrees Celsius surface temperature, 92 atmospheres of pressure, sulfuric acid clouds, permanent greenhouse inferno. Mars, cold, thin atmosphere, no magnetic field, radiation-blasted surface, dry. The gas giants, no surface at all, just storms and pressure and crushing gravity. The ice giants, frozen, tilted, strange. The moons, some have oceans, yes, but under ice, in darkness, no oxygen, no life. And then there's Earth. Liquid water on the surface, breathable atmosphere, moderate temperatures, magnetic field, active geology, stable climate, and life. Everywhere, in every environment, filling every niche. We thought this was normal, the default state for rocky planets in the habitable zone. It's not. Earth is the weird one. Earth is the only planet in the solar system with active plate tectonics. Let that sink in. Mercury doesn't have it. Venus doesn't have it. Mars doesn't have it. None of the moons have it, except possibly Europa's ice shell, which isn't the same thing. Earth's lithosphere, its crust and rigid upper mantle, is broken into about 15 major plates. These plates move, collide, pull apart, slide past each other. And this one feature drives everything. At divergent boundaries, mid-ocean ridges, plates pull apart. Magma wells up from the mantle, creating new crust. The entire ocean floor is replaced every 200 million years. Iceland sits on one of these ridges. The island is literally being pulled apart at 2.5 centimeters per year. In 10 million years, it will be 2 separate islands. At convergent boundaries, plates collide. One slides beneath the other, subduction. The descending plate melts as it sinks into the mantle. That melt rises back up as volcanoes. The Ring of Fire, the volcanic arc around the Pacific, marks these collision zones. Every major earthquake, every explosive volcano, every mountain range formed by collision. The Himalayas exist because India crashed into Asia 50 million years ago and is still pushing. Mount Everest grows 4 millimeters taller every year. At transform boundaries, plates slide horizontally past each other. The San Andreas Fault in California, the North Anatolian Fault in Turkey. No volcanoes, just earthquakes. These boundaries are scars where the planet's surface grinds against itself. But plate tectonics doesn't just make mountains and earthquakes. It regulates climate. Carbon dioxide dissolves in rainwater, forming weak carbonic acid. That acid weathers rocks, pulling carbon out of the atmosphere and locking it in minerals. Rivers carry those minerals to the ocean, where they settle as sediment. Over millions of years, that sediment gets subducted, cooked, melted, and the carbon returns to the atmosphere through volcanoes. This is the carbonate-silicate cycle. It's a thermostat. When Earth gets too hot, more rain falls, more weathering occurs, more carbon gets pulled from the atmosphere. Earth cools. When Earth gets too cold, less weathering occurs. Volcanoes add carbon faster than weathering removes it. Earth warms. Plate tectonics created this feedback loop, and it's kept Earth's climate stable for billions of years. Venus doesn't have this. Venus is Earth's twin in size and mass. Same distance from the Sun, roughly. Same composition. But Venus has no plate tectonics. Its lithosphere is one solid shell. Stagnant lid. No subduction. No carbon cycle. And without that cycle, carbon accumulated in Venus's atmosphere until it triggered a runaway greenhouse effect. Temperatures soared to 465 degrees Celsius. The oceans boiled away. The water vapor escaped to space, leaving Venus dry, dead, and permanently hellish. Liquid water helped Earth develop plate tectonics. Plate tectonics helped Earth keep liquid water. Venus never had the chance. Mars had volcanism, maybe brief periods of tectonic activity billions of years ago. But Mars is small. It cooled faster. Its lithosphere thickened into a single stagnant lid. Without plate tectonics to recycle carbon and regulate climate, Mars couldn't maintain a thick atmosphere or liquid water on its surface. It froze, dried, died. Earth has had plate tectonics for at least 1.8 billion years, possibly 3 billion. Scientists recently reconstructed the entire dance of continents over that time. Watching the animation is mesmerizing. Supercontinents form, break apart, reassemble. Rodinia, Pangaea, Gondwana. Each configuration lasted hundreds of millions of years before fragmenting. And through it all, ice ages, asteroid impacts, volcanic eruptions, plate tectonics kept Earth habitable. It's the reason we're here. And then there's the Moon. Earth's moon is enormous relative to the planet it orbits. At 27% of Earth's diameter and 1.2% of its mass, it's the largest moon relative to its planet in the inner solar system. Mars's moons, Phobos and Deimos, are tiny captured asteroids. Mercury and Venus have no moons at all. Earth has a companion. The leading hypothesis for the moon's formation is violent. 4.5 billion years ago, a Mars-sized object named Theia slammed into the young Earth at an oblique angle. The impact vaporized both Theia and a chunk of Earth's mantle. That debris coalesced into the moon. This wasn't a gentle process. It was catastrophic. But it gave Earth something no other inner planet has: a massive, stabilizing companion. Earth's rotation axis is tilted 23.5 degrees from vertical. This tilt gives us seasons, but without the moon, that tilt would be chaotic. Earth's axis would wobble dramatically over tens of thousands of years, swinging from nearly 0 degrees to 85 degrees. Imagine the climate chaos. Polar regions becoming tropical, equator freezing. No stable climate zones, no predictable seasons. Mars doesn't have a large stabilizing moon. Its axial tilt has varied from 13 to 40 degrees over the past 20 million years. When the tilt is high, Mars's poles receive more sunlight, ice sublimates, and the atmosphere thickens temporarily. When the tilt is low, everything freezes solid. Mars's climate is chaotic, always has been. Earth's moon keeps our tilt stable, keeps our seasons predictable, keeps our climate zones fixed long enough for complex life to evolve and adapt. The moon also creates tides. Twice a day, the moon's gravity pulls Earth's oceans toward it, creating tidal bulges. As Earth rotates beneath those bulges, we experience high and low tides. Tides mix the oceans, circulate nutrients, create intertidal zones, ecosystems that exist between land and sea. Some scientists think tidal pools were the crucible where life first emerged. Shallow water, concentrated organic molecules, cycles of wet and dry. Without the moon, our tides would be minuscule, driven only by the sun's gravity. No tidal pools, no intertidal zones, possibly no life. The moon is leaving us. Tidal friction slows Earth's rotation and transfers angular momentum to the moon, pushing it away at 3.8 centimeters per year. 4 billion years ago, the moon was much closer. Days were just 6 hours long. Tides were enormous, hundreds of meters high. Billions of years from now, the moon will be so distant that it no longer stabilizes Earth's tilt. Our axis will begin to wander. Climate will destabilize. But that's tens of millions of years away. For now, the moon remains our guardian, our stabilizer, our companion in the dark. Earth has something else most planets lack: a strong, stable magnetic field. Generated by a dynamo, convective motion of molten iron in Earth's outer core, the magnetic field extends 65,000 kilometers into space, creating a protective bubble called the magnetosphere. And it's saving our lives. The sun constantly emits charged particles, the solar wind, traveling at 1.5 million kilometers per hour. When those particles hit Earth's magnetosphere, they're deflected around the planet. Some particles funnel down magnetic field lines near the poles, colliding with atmospheric cholesterol and creating auroras, the northern and southern lights. Beautiful, but also evidence of a process that would strip our atmosphere away if not for the magnetic field. Mars once had a magnetic field. Evidence from ancient rocks shows it. But Mars's core cooled. The dynamo stopped. The magnetic field collapsed. Without that shield, solar wind began stripping Mars's atmosphere directly. Over billions of years, Mars lost most of its air. What remains is less than 1% of Earth's atmospheric pressure. Mars dried, froze, became the cold desert we see today. Earth could have suffered the same fate, but our core remains molten. The dynamo persists. The magnetic field holds. Venus has no magnetic field either. Its rotation is too slow, 243 Earth days to complete one spin. So the core doesn't generate enough convective motion to sustain a dynamo. Without a magnetic field, and with a thick atmosphere already, Venus doesn't lose much atmosphere to solar wind. but it also has no protection against radiation. Earth's magnetic field deflects not just solar wind, but cosmic rays, high-energy particles from exploded stars. Without this shield, surface radiation would be much higher, possibly lethal to complex life. Earth's magnetic field isn't permanent. It flips, reverses polarity. On average, the field reverses every 200,000 to 300,000 years, sometimes more frequently, sometimes not for millions of years. We're overdue. The last reversal was 780,000 years ago. The field is weakening. Some scientists think a flip might happen within centuries. During a reversal, the field doesn't disappear. It just gets weaker and more complex, with multiple poles. But even weakened, it's better than nothing. Mars and Venus have no field at all. They're naked to the solar wind. Earth remains shielded. And then there's distance from the Sun. Earth orbits at one astronomical unit, 150 million kilometers. Close enough to receive warmth, far enough not to boil. This is the habitable zone, the Goldilocks zone. Not too hot, not too cold. Venus is just inside the inner edge. Mars is just outside the outer edge. 30 million kilometers closer, and Earth might have suffered Venus's fate. 50 million kilometers farther, and Earth might be frozen like Mars. But distance alone isn't enough. We also have Jupiter. Jupiter's massive gravity acts as a shield, deflecting long-period comets that would otherwise bombard the inner solar system. Simulations suggest that without Jupiter, Earth would experience 10 to 1,000 times more impacts. The dinosaurs got unlucky once. Without Jupiter, extinction events would be far more frequent. Complex life might never have had time to evolve. But Jupiter also delivered water. Earth formed in the inner solar system, where temperatures were too high for water ice to condense. We were born dry. But comets and asteroids from the outer solar system, where water ice is stable, bombarded early Earth. They delivered oceans, possibly organic molecules too. Jupiter's gravity scattered these objects inward. The same force that shields us today might have seeded us with water billions of years ago. And then there's the atmosphere. Earth's atmosphere is 78% nitrogen, 21% oxygen, 1% argon, and trace gases. That 21% oxygen is life's doing. Cyanobacteria started producing it 2.4 billion years ago through photosynthesis. No other planet has free oxygen in its atmosphere. It's a biosignature, evidence of life. If aliens aimed telescopes at Earth and analyzed our atmosphere, they'd see oxygen and methane coexisting, chemically impossible without biology constantly replenishing them. Earth's atmosphere shouts, life is here. And liquid water on the surface. Not under ice like Europa, not as methane like Titan. Liquid water. Oceans covering 71% of the planet. Water is transparent to visible light, allowing photosynthesis in the upper ocean layers. Water has high heat capacity, moderating temperature swings. Water expands when it freezes, so ice floats, insulating liquid water beneath. These properties made life possible. And plate tectonics, the moon, and the magnetic field kept water liquid for billions of years. The result? Life everywhere. From thermal vents at the bottom of the ocean to the upper atmosphere. From Antarctic ice to boiling acidic pools. From radiation-soaked rocks to inside other organisms. Life fills every available niche on Earth. 8 million species, trillions of organisms. No other planet has this. None even come close. So let's review what we've learned across all 10 episodes. Io has more volcanic activity than any world we've seen. Tidal forces squeeze it, melt its interior, and erupt sulfur across its surface. Earth has volcanoes too, but they're regulated by plate tectonics and create habitable land. Europa and Enceladus hide subsurface oceans, kept liquid by tidal heating, in darkness, under ice. Earth's oceans are on the surface, in sunlight, full of life. Titan has methane lakes and an alien water cycle, chemistry we've never seen. Earth has water lakes, water rain, a cycle that sustains life. Jupiter and Saturn have storms larger than our planet, weather systems that dwarf anything on Earth. Earth's weather is mild by comparison. Hurricanes are bad, but they don't last centuries. Mars lost its atmosphere and water, froze, dried, died. Earth kept its atmosphere, kept its water, thrived. Pluto, 3.7 billion miles from the Sun, is geologically active, with ice blades and convecting glaciers. Earth's geology is driven by internal heat and plate tectonics, but our activity creates mountains and fertile valleys, not methane spires. Miranda, Phobos, Triton, oddball moons with chaotic histories. Earth's moon is large, stable, and keeps our planet habitable. Pluto, the Kuiper belt, far, far out, the edge of sunlight where everything is frozen. Earth orbits in the warm zone, Goldilocks. Asteroids and comets, time capsules that remember the solar system's formation. Some threaten extinction. Earth has learned to track them, deflect them, survive them.
Every world we explored was extreme, hostile, alien.
And then there's Earth, the one with liquid water, breathable air, stable climate, magnetic shield, giant stabilizing moon, active plate tectonics that regulate carbon and prevent runaway greenhouse or icehouse states. The one with life. For 9 episodes, we've been looking for what makes other worlds weird. We should have been asking, what makes Earth survivable? We've discovered over 5,000 exoplanets, worlds orbiting other stars. Some are hot Jupiters, gas giants orbiting closer to their stars than Mercury orbits the Sun. Some are super-Earths, rocky planets 2 to 10 times Earth's mass. We don't have one of those in our solar system. Some are ice giants, lava worlds, rogue planets drifting between stars. But so far, we haven't found another Earth. Not exactly. We've found planets in habitable zones, Proxima Centauri b, the TRAPPIST-1 system. But being in the habitable zone doesn't mean you're habitable. Mars is in our habitable zone. It's frozen and dead. Venus might have been in the habitable zone when the Sun was younger. It's now hell. Distance from the star is necessary, but not sufficient. You also need plate tectonics to regulate carbon and climate, a large moon to stabilize axial tilt, a magnetic field to shield the atmosphere, the right amount of water, too much equals water world, too little equals desert, a Jupiter-like planet to clear debris and deliver water, luck, avoiding runaway greenhouse, snowball states, extinction level impacts. How many planets have all of this? We don't know. But the fact that Earth is the only one in our solar system suggests it's rare. The Fermi paradox asks, if life is common, where is everybody? Maybe the answer is simpler than we thought. Maybe Earth-like planets, planets with all the right features in all the right combinations, are extraordinarily rare. Maybe we're not looking at a universe full of Earths waiting to be found. Maybe we're looking at a universe full of Venuses, Mars, Titans, and Europas. And maybe, just maybe, Earth is the weird one. December 7th, 1972. The blue marble, the most reproduced image in history. For 50 years, we looked at this photograph and thought, this is what planets look like. Blue oceans, white clouds, green continents, life. We were wrong. This is not what planets look like. This is what Earth looks like. Planets look like Mercury, cratered, dead. Planets look like Venus, hellish, runaway greenhouse. Planets look like Mars, frozen, dry. Planets look like gas giants, no surface. Planets look like ice giants, tilted, strange. Moons look like Io, volcanic, sulfuric, or Europa, oceans under ice, in darkness. Or Titan, methane rain, alien chemistry. Or Miranda, shattered, reassembled wrong. Earth doesn't look like any of them. Earth is the anomaly, the outlier, the one weird planet that got everything right. Plate tectonics to regulate climate, a giant moon to stabilize the axis, a magnetic field to shield the atmosphere, the right distance from the sun, liquid water on the surface, and time, billions of years without catastrophic disruption, for life to take hold and flourish. 7 billion people live on this planet. Most will never see it from space. Most will never see the thin blue line of atmosphere that protects us. Most will never realize how improbable this is. We spent 9 episodes exploring alien worlds, seeking wonder, searching for strangeness, and we found it everywhere. But the strangest world was here all along. The one with oceans you can swim in, air you can breathe, soil that grows food, a moon that stabilizes seasons, a magnetic field that shields life, plate tectonics that prevent runaway climate death. The one world, out of everything we found, where we can exist. This is Cosmic Canvas, where we explored the solar system to understand our place in it. And after 9 episodes, 60 worlds, and billions of miles, we learned something simple. Earth isn't normal. It's not the baseline. It's not what planets are supposed to be. Earth is weird. Impossibly, beautifully, precarious weird. And that makes it the most extraordinary place in the known universe. Take care of it. There's nothing else like it.